Hey, Todd Usher with Addison Homes, and today we're going to talk about bathroom ventilation. So bathroom ventilation isn't necessarily a very sexy topic, but it's one that's extremely relevant not only to the comfort of our homes, but humidity control, which is directly tied to comfort. And in this case, I want to talk about what's required by the building code, what we consider to be the minimum legal allowable standard for building a home to, and what truly works. So I'm walking through a townhome project that's being built by one of the production builders in our market, and I see what I frequently see in many homes that I walk through under construction. And that is a bath fan that will in no way, shape, or form meet the ventilation requirements for removing humidity from a bathroom that contains a shower or a tub. And in this case, the bath fan is grossly inadequate, and it's been installed in a way that it will never perform. So one of the keys for bathroom ventilation is that we're exhausting the sources of humidity in our buildings. When we build a well-insulated, tight home, we want to exhaust point sources of humidity out of the house. We don't want those just sitting in the house. So after we take a shower or a bath, we want that humidity to be exhausted to the outside. And what I commonly see, especially in production-built homes, but even in custom homes in this area, is inadequate bathroom ventilation. And when I talk about inadequate bathroom ventilation, it's a couple of components. Number one, I see a lot of cheap bath fans used. Fans that don't really move much air, but make a lot of noise. I call those just noise makers. So we have bath fans that are noise makers, which are the ultra cheap, and we have bath fans that actually operate to move air and exhaust that air to the outside. The second component in adequate bathroom ventilation is sizing the exhaust duct properly and using the correct type of ductwork on the exhaust lines. So three drawbacks with the installation that I'm looking at here for this bath fan. Number one, the bath fan itself is probably the cheapest type that can be purchased. So trying to hit a cost ballpark, this bath fan might be a $25 or $30 bath fan versus a $100 bath fan. So it doesn't have the ability or the power to really move air over a long distance. Problem number two, the ductwork off of this bath fan is only 3-inch in diameter. That's what we find on the less expensive bath fans. They have smaller diameter duct connections and can only accommodate small diameter duct runs for a very short distance. Most bath fans that I would consider adequate would either use a 4-inch diameter duct or a 6-inch diameter duct, depending on how much air it was moving and how far it was moving that air. The third problem with this bath fan is that that duct is not only 3 inches diameter, but it's flexible duct. And that flex duct, while it's okay for very short runs, it's not good for long runs. Think trying to drink through a straw that's 100 feet long. A lot harder to move fluid through that straw over a long distance. Air is a fluid, and moving air through a 3-inch diameter duct that's flexible duct with a lot of turbulence and resistance is very difficult. Then the last problem with this bath fan is that that flex duct runs over 30 feet in distance. So they're running the bath fan from this bathroom all the way to the back of the building 30 feet, when just turning it 90 degrees could cut that distance in half and run it perpendicular out the side of the building. So 4 problems with the bath fan on this particular project that we commonly see when we walk through new construction that meets code but doesn't embrace the latest best practices of high performance building. Those problems are poor quality bath fans to begin with, small diameter ducts, flexible duct runs instead of hard pipe duct runs, and long duct runs, 30 feet in this case. There's no way this bath fan is ever going to perform in an adequate manner to remove humidity from this bathroom and to cut down on the issues that humidity might cause. Even though this bath fan behind me is grossly inadequate for what the best practices standards would require, it's allowed by code. And that's all I want to point out, is that there is the building code and then there are best practices. Builders who just build the code, there's a place for that, and would argue that in order to meet certain cost limitations, they have to just simply build to the minimum legal standard. I would argue that when we embrace best practices and then become efficient at implementing those best practices, we can build performance into our homes without settling for the minimum allowable standard. And we can truly build homes that work, homes that perform, homes that our residents can truly be proud and comfortable to call home. If you've liked this video, please subscribe to our channel and follow us for future videos to come that are focused on educating all of our viewers on the differences in high performance building and simply built to code.